Good morning and welcome to Algebra 1. It's Friday, April 24th. Today I'm going to go through how to do all of the questions that I had given you on the test prep worksheet. Remember that was not required for you to send to me, but obviously it's a good idea to have done it. So here's how we solve the problems, all right? We'll take it one by one. The first one gave you a system, y equals negative a half x, plus 4 and y equals x minus 2. I asked you to solve it using graphing. You had a coordinate grid on your worksheet. I'm just going to try to make my best version of one here. Obviously, using the grid I gave you on the worksheet is a better idea than making your own grid because these tick marks and my placements are not going to be perfect. However, here's what I would do. I see a y-intercept of positive 4, so I go up 1, 2, 3, 4, put a dot there. The slope is negative 1/2, down 1 over 2, down 1 over 2. Here is my line, or roundabout where it would be. The other line starts at a negative 2 y-intercept, so I go down 2 on the y-axis and put a dot there. And then the slope of x here is just the number 1. It goes up 1 and over 1, up 1 over 1, and I will draw my line as best I can. Now again, I drew this freehand. I didn't have a coordinate grid system. I'm not, really positive about my answer. So here's what I'm going to do. First, I'm going to identify my solution. I believe the solution is 1, 2, 3, 4, 1, 2. So I think 4, 2 is my answer. Okay, well, how do I verify my answer is correct? I plug it in. 4, 2 should work for both of those lines. If it doesn't, it's wrong. So that's x, that's y. If 2 equals negative a half times 4 plus 4, then it works for the first equation. 2 equals negative 2 plus 4. It looks like that does work because 2 equals 2, and that's what it's supposed to equal. The other line, I have to check that as well. Does 2 equal 4 minus 2? I'm pretty sure we can see it does. 2 does equal 4 minus 2. I got it right. So 4, 2 is the first solution there. And you should have solved it by graphing, and you should have checked it by plugging it in. All right, moving on. Number 2. All right, so you're supposed to solve number 2 with substitutions. X plus y equals 6, and I gave you y equals 2x minus 9. So you're told to use substitutions. You can do one of two things. You could put this in slope-intercept form and then set the quantities equal to each other, or you could just take this whole thing. See, it says 2x minus 9, and that's what y equals. You could plug it in for y. Either which way is fine. I'm going to do that because it is just easier. So I'm going to take that and I'm going to plug it in right there in place of y. X plus 2x minus 9 equals 6. It's substitutions. The fact that it says plus over here means I can just drop the parentheses. It doesn't make any difference. And now I'm going to combine like terms. So I have 3x minus 9 equals 6. I'm going to add 9 to both sides. 3x equals 15. I'm going to divide by 3. X equals 5. Cool. I'm not done. Remember that the coordinate is the solution, not a single value. I need to find out what y is. And right here, it actually identifies what y is equal to 2x minus 9. So I'm going to use number 5 as x, 2 times 5. Minus 9, that's 10 minus 9, that's 1. My solution is the coordinate 5, 1. If you want to verify, which is always a good idea, you should plug it in to see what you get. If I plug in 5 for x, 2 times 5 is 10, 10 minus 9 is 1, which it's supposed to. In the other one, if I plug in 5 and 1, 5 plus 1 equals 6. Well, I'm sure it does. So it's the right answer, and I confirmed it. That's substitutions. Moving on to number 3. By the way, I know you guys know that you can pause the video, rewind the video, listen to it again. I'm not that worried about going too fast right now because you have that capacity. Number 3, let's see what number 3 asked you to do. We had to solve with eliminations. 2x minus y equals 15 and x plus 2y equals 20. Correct? Correct. All right, eliminations means I have to eliminate one variable pair. I think if I multiply the top row by 2, that'll become a -2, canceling out the +2. I find that to be the easiest thing to do, so it's what I'm going to do. It will distribute to all 3 parts. 4x minus 2y equals 30. Now I have standard form. They're stacked vertically. I have an opposite variable pair. I'm just going to add. X plus 4x is 5x. The y's are canceling. 20 and 30 is 50. We divide by 5. X equals 10. Cool. Still have to find out what y is. So I'm just going to take the equation that said x plus 2y equals 20 and plug in a 10 for x. And subtract 10 from both sides and divide by 2, and I get y equals 5. The solution is 10, 5. Again, if you want to verify it, you can always plug it in. If I plug in 10 for x and 5 for y, 10 plus 2 times 5, which is another 10, is 20. Plug in 10 and 5. 2 times 10 is 20, minus 5 is 15. It does work. It's always a good idea to double check. And that was 3. Okay, number 4. I think you were left to your own as to what method you wanted to use for number 4. So I'll say we had this equation and we had 2x plus 2y equals 6. Please note that I don't put them stacked vertically when they're not in standard form. I just separated them because I know I have to do work with them. I am going to just plug this in. So substitutions, this goes in right there. So we get 2x plus 2 times negative x plus 3 equals 6. It's just substituted the values in. Now I have to distribute that 2 right there. So 2x minus 2x plus 6 equals 6. On this side, 2x minus 2x combines to be nothing. It drops out. And all I have here is 6 equals 6. Well, you know, there's no variables anymore, but it's a true result. What did I say that means? Oh, it means that those 2 lines, they were the same line. So there are infinite solutions. And we can say that same line and infinite solutions. Again, what that means is there isn't just one place where they cross and therefore there's one solution. They cross everywhere because they're the same line graphed on top of itself. Okay, that was a special system. Special systems are solved when the variables both cancel out and the result you get is a true statement. 6 does equal 6. So what do you think the other number 4 question could have been? Call it 4b. Well, you had x minus 3y equals 4, and you had y equals 1/3 x plus 2. Once again, I got to solve this somehow. What should you do? Well, it's really up to you. I'm going to do the same thing I did last time. Plug this into y. It was already set up that way. It makes it easier anyway. X minus 3 times 1/3 x plus 2 equals 4. Do not be afraid of multiplying a whole number by a fraction. We've done it time and again. It's the whole number times the numerator divided by the denominator. It is not hard. So I'm going to do that now. X minus 3 times 1 is 3, divided by 3 is 1. It's 1x, or just x. And negative 3 times 2 is minus 6 equals 4. What does x minus x on the left side of the equation turn into? Nothing. It cancels out. X minus x is nothing. So I'm left with negative 6 equals 4. It does not equal 4. So it's the equation's way of telling us there is no solution. The variables both dropped out, but the result this time was false. -6 does not equal 4. So there is no solution. What kind of a system has no solution? Parallel lines. They don't cross. Okay, so we'll say parallel lines. You could use the symbol for parallel. So far, so good. Okay, then let's look at what comes next. Well, after number 4, I gave you number 5, the linear inequality system. And we had y is less than or equal to 1/2 x minus 4. And also y is greater than -x plus 2. You had to graph it. I gave you the graph for that reason. So I'll make my rough graph here. Obviously, it won't be perfect scale-wise, but hopefully the graphing will be good. I have the first equation's y-intercept is -4. So I'm going to go down 4 and put a dot. Then I have a slope of 1/2, up 1 over 2. It says less than or equal to, which meant that we're going to use a solid line. So here's my solid line. I showed you that I put a stick figure guy on the line and I shade appropriately. Less than or equal to is under the guy. So this is shading down from the guy's feet, all the way down there. All right, the other line we had has a y-intercept of +2. So right over here. Its slope is -1. Again, x isn't part of the slope. So it's -1. It goes down 1 over 1. So down 1, right 1, down 1, right 1. It says greater than, not or equal to. So it's a dotted line. So I'm going to put my dotted line here. I'm going to put my stick figure guy standing on the line. And it says greater than. So it's above the guy. It's all around the guy. It's just not below him. So we're going to shade up from the guy. And what I see is that this area of cross shading, this is really the solution to the problem. It's where the shading overlaps. I told you that we can always check a solution by choosing a coordinate within the shaded region. I hand drew this, so it's kind of hard to see exactly what the numbers would be, but I'm going to choose, let's say, 10, 0. 10, 0 is certainly inside the shaded region, right? So I'm going to choose 10, 0 and see if it works. If it works, I shaded correctly. If not, I didn't. So, checking it out, does 0 turn out to be less than or equal to 1/2 of 10 minus 4? Is 0 less than or equal to 5 minus 4? Is 0 less than or equal to 1? It sure is. Similarly, on the other line, we have 0 is greater than -10 plus 2. 0 is greater than -8. Yes, it is. I shaded correctly. You guys might have noted that if you did the quiz correctly and you checked your work, you got bonus points for it. Okay. Looks good? Looks good to me. That brings us to number 6. And 6A and B, those were your word problems. Okay. So it helped you to practice writing a system of equations and then solving it from the word problems. I think they were pretty straightforward, so let's see if you got them right. Number 6, we have a house with two kinds of creatures, people and tarantulas, because why not? Now, I said that in number 6, part A, there were 10 creatures. We got people, we got tarantulas, we got 10 things in the house. I said there were 44 eyes in the house. People have 2 eyes, tarantulas have 8 eyes, and that's 44 eyes. The question was, how many people and how many tarantulas are there? It sets up nice and easy in standard form, which means the best thing to do is eliminations. To cancel out, let's just say the P I'm going to multiply by -2. And again, of course, that distributes to all three aspects here. -2p minus 2t equals -20. And now I'm going to add. Now the 2p plus -2p cancels out, which was the point. 8t plus -2t is 6t. 44 plus -20 is 24. We divide by 6, and we find that there are 4 tarantulas in the house. Hopefully they're in some kind of terrarium and not just roaming the house. That'd be horrible. Obviously, if there's 10 creatures, I'm not even going to bother putting the math on paper. There's obviously going to be 6 people. If there's 4 tarantulas, there have to be 6 people. You want to double check it? Sure, 4 and 6 is 10. But the eyes question, if I have 6 people, 2 times 6 is 12 eyes. If I have 4 tarantulas, 8 times 4 is 32. 32 and 12 is, fortunately, 44. We got the answer right. And we'll have to question these people's choice of pet. Part B. I deliberately gave you a question that would set up with the other style, not the standard form style, but the slope-intercept style. So I gave you competing babysitting rates. We got Karen. Karen charges you $20 to show up, and then $5 for every hour of babysitting. And then Susan, who charges $12 to show up, which is obviously cheaper, but $7 per hour for the babysitting itself, which is obviously more. So if you have a short job to do, it looks like Susan's probably your best bet. But if you have a longer job to do, Karen might be the way to go. So let's just set up the 2 equations here for 6b. I have Karen, so I'll say K equals. She charges $20 to show up and $5 per hour, 5H. Pretty easy. And I got Susan, S, and Susan charges $12 to show up and then $7 per hour. The question was, for how many hours is one cheaper than the other, or at what point are they the same? I think that was the phrasing. And then who should I hire if I have a 6-hour job? These are in slope-intercept form, and they're both set so that I can just make them equal each other. That's the substitutions method for a slope-intercept. So when does 20 plus 5h equal 12 plus 7h? That's the question. Because if I find out when they equal each other, I find out how many hours of sitting will result in the same fee. I'm going to, let's say, subtract 5h from both sides. If I subtract 5h, I get 2h over there. I'm going to subtract 12 from both sides. 20 minus 12 is 8, equals 2h. I'm going to divide by 2. And I find out that in 4 hours' time, their fees are the same. Okay, so again, Karen starts out more expensive than Susan. After 4 hours' time, their rates are going to cross, and then it's going to go the other opposite direction. So a quick answer is, if I have a 6-hour job, that means that I should hire Karen. But if you're not sure, let's plug in 6 hours and see what they'd equal. So Karen is going to cost 20 plus 5 times 6. 5 times 6 is 30. So Karen's going to cost me $50. But Susan is going to cost 12 plus 7 times 4. Okay, so not 4, 6. Use the wrong number there. What is 7 times 6? 7 times 6 is 42. 42 and 12 is $54. So Susan's more expensive for the 6-hour job. And obviously Karen will be a little bit of a cost savings. Why I'm hiring a babysitter in a pandemic, I couldn't tell you. Now, that's it. That's all that the test prep worksheet was, and that's all that your test is going to be. So I need you to make sure that you could do all these questions. If you have any problems, any issues, please email me directly. Otherwise, your test will post on Monday, and I'll ask for you to have it to me by, let's say, Tuesday afternoon. I think it sounds fair. If you have any questions, please let me know. Have a wonderful weekend.